Good morning. How's everyone doing? Good. Doesn't sound like you're good. You're really quiet. We awake yet? There is coffee. So this is going to be a little suspenseful, as you can see. Halloween, October 31st, 2018, two Black Hills security researchers, Bo Bullock and Michael Felch, had discovered and disclosed to Google step by step how anyone with a Gmail account could inject into anyone else's Google Calendar an event, not just an invite, an event as accepted. So Google called this a feature. Almost a year later, well, no, it's actually past a year later now. Yeah, this attack still works. So this is why I entitled this talk, "What the fuck, Google? How is this still not fixed?" Really, no, it's not. It's called Calishing, a red team approach to weaponizing Google Calendar and how to stop it. I'm Antonio Piazza. I go by Ant-Man on Twitter. I'm a former United States Army 35 Mike, which is a human intelligence collector. That was my former life, so I was an interrogator / liar, professional liar, professional lie detector. That training that I had, along with my psychology degree from Ohio State many years ago, kind of helped me translate that into social engineering. So that's kind of what I focus on the red team side of things. I do a lot of other things, but that seems to be where my focus lies. I was also on a NSA certified red team for United States Air Force for a short period of time. And I'm currently, then I was a red teamer at the Cleveland Clinic, and now I am currently a red teamer at Box in Austin, Texas. A little bit about me. So an update to this talk. Back around DerbyCon time, there was a nice article put out by Forbes that they decided to hype up this idea that Google is going to fix this, or is working on fixing this problem. And they wrote this entire article strictly based on this one post in a Google forum by a Google employee that they're working on this. I'm a little bit of a conspiracy theorist. I don't think that one post was enough to write this great article that Forbes created. But Forbes ran with it, and without interviewing anyone at Google or anything else. So this is what we have right now for this fix. This is the agenda. I'm going to talk about what Calishing is, why it's relevant to both red and blue teams. I'm going to actually do the attack by the numbers. So if you have your laptop and you want to follow along, feel free. You can do this to your friends right now. That's my GitHub repo. If you want the tool to do this, you can grab it right now. Just do a git pull. And you're also going to need the Python's request library, and you can do a pip install request, and you're good to go. And if you can't see that link, you can basically just do a search for GitHub Ant-Man 1P, and you'll find a tool called G-Calisher. So what is Calishing? Well, I made the word up, and I put it on Urban Dictionary. You can do a Google search for Calishing, and I think, at least on my computer, on my Chrome, it's the #1 result. I don't know if that's the case in everybody's. But what it is a fraudulent practice of injecting events into web-based calendars purporting to be from reputable sources in order to induce victims to infect their computers with malware. Used in a sentence, this Google Calendar event is likely a Calishing scam, or I'm going to Calish these fools and get a shell on their Mac. So why is this talk relevant to red and blue teams? We'll talk about the red side first. It's really effective at getting shells. I've used it several times in my environment. The attacker can embed a link, and I'll demonstrate that later. That can be a download link to your malware that you created as a red teamer. I work in an all Mac environment, just to let you know. So this does work for Macs, and I'm pretty sure it'll be a lot easier in Windows. You can make the link look like, for instance, a Zoom link or a Google Hangouts link. So if you're attacking, let's say, client-facing sales or support folks in your business, it's really effective because those people add stuff to their calendars all the time, right? They don't necessarily know if something pops up and says, "Hey, you have a Zoom meeting in 5 minutes with so and so." Like, oh, I guess I set that meeting up. The attack works because it's injected as if they accepted the invitation. There's no invitation; it's just accepted. It's on their calendar saying, "Hey, you have this coming up." You can rush the victim into clicking the link. You can make it look like the event's going to happen in 5 minutes. And in social engineering, that's a good trick. That you're running out of time. You have something coming up really fast, makes that anxiety level go up, makes somebody click something without thinking about it. In social engineering, we don't want them to think. We don't want them to use logic. We want them to react from emotions. So you get that fear. Oh, I have a meeting. I have to hurry up and click this. It's also effective at establishing your command and control. If you have a piece of malware that you make them click on, and you can get them to start calling out to wherever your C2 is. I happen to use like GCP up in the cloud. It's super convincing. So, blue team side. Well, what's good for red is good for blue, right? And I'm talking about red teaming. The definition of red teaming that I have is where you are strictly there to train the blue team. Like I'm not there to pen test. I'm not there to check the security of certain parts of the network or anything. My sole job as a red teamer is to train the blue team, make them flex their muscles and get used to all the tactics and techniques that a real world adversary would use. So anything that I do that I expose them to makes them better. And that's my philosophy on things and other people's philosophy as well. You get to implement new tooling. You get to help them create new alerts, signatures. You get to help them figure out what they do as far as an instant response. What their process is, how their processes can be changed to adapt to this newer technique. Relevance continued. I don't think you're going to be able to read this. But I did a little research, and out of Fortune 1000 companies in Silicon Valley, about 17% are using G Suite or using Google Calendars in their businesses. So 6 out of 37 I found, and then I did some more research and just checked some random businesses like Lucasfilm, IBM, Pixar, not necessarily in the Fortune 1000, but about 37% of the 27 that I looked into are using G Suite. So as a red teamer, if you're working in, this wide array of industries, it's very relevant to you because again, it's an effective attack vector. So I'm going to go into this is the attack by the numbers part. So I don't know if any of you, I don't see anybody with their laptops out or anything, but if you want to follow along, this is going to be kind of boring if you're not, because I'm going to go step by step in how this actually works. This is the Calishing kill chain. First, I'll talk about, before I actually go in hands-on how to go step by step through this, I'm going to talk about some of the steps that you can take as a red teamer. First thing you can do is recon. I'm not sure how many of you are familiar with dig. Tool's really good for doing recon. And so sometimes if you ran this dig command, sometimes it's really obvious that you'll find that this company uses G Suite for their email. Obviously, Google.com. You dig their MX records, it shows you they use Google. Sometimes it's not as obvious. And for instance, CrowdStrike, if I do a dig on their MX record, they have this PP hosted, which is Proofpoint. So they're using some sort of email protection, right? So you don't necessarily see Google. But at least you know that they have some sort of cloud protection going on if they're using Proofpoint, right? So if you actually do a dig and instead of the MX record, you do a TXT record, you might see this SPF for google.com, right? Anybody know what SPF is? Familiar with SPF? So it's a sender policy framework, and it's a protection from spoofing. So in my research, I was pretty surprised by the lack of using SPF. And does anybody know what can happen if you don't use SPF to protect your email? So yeah, people can spoof you. So you basically can, let's say Twitter didn't have an SPF, I could send an email to anybody saying I'm from twitter.com, right? And there's a surprisingly large number of companies out there that don't use SPF. But anyway, that's kind of outside the subject. But the point here is that in those SPF records, you can see where the actual email domain is. So Twitter uses G Suite. Finally, my partner at Box, Cedric Owens, he wrote a tool called Gobbler. It's a Python 3 tool, a domain recon tool. You can get it. Ced Owens is his Twitter, and here's his GitHub. The tool is really good for doing recon. It will give you a ton of information on a domain when you put it in, and including, probably can't see this, but the SPF records as well. So that's a great tool if you're doing recon beforehand, trying to figure out. And this is more for a red team consultant than an in-house like I am. Obviously, I don't really have any need for trying to find out if Twitter is using Gmail, but for those of you that do consultant work, this recon stuff is pretty important for this attack. So now we're going to go through, again, this is what I'm talking about, the step-by-step of how to do this. The first thing you're going to need to do is the main goal of all these steps is to get your API key so you can actually communicate with Google Calendars. So the first thing is just creating a new Gmail account or using the old one that you have already. You want to, when you're creating the Gmail account for a red team operation, you want to give it some sort of name that will go with your whole, I guess, social engineering persona that you've built. So, for example, let's say I was wanting to pretend to be from a company like Carbon Black. I would put T Jones for Tom Jones .carbonblack@gmail.com, right? Something that'll confuse the victim that you're trying to attack. So next thing you're going to do is you're going to go to this site. It's the Google developers site. You're going to create or select a project if you already have one. Go through, agree with the terms of service. You'll click continue, and then you choose the terms of service for whatever country you're in. Me, it would be the U.S. You're going to name your project. Doesn't matter what you name it. This part nobody's going to see. Click create. And then you're going to click go to credentials. But you're going to skip over this part, actually. When you go to credentials, you're just going to hit cancel, and you'll come back to actually adding your credentials in a later step. So on the left side of the page, you're going to see select OAuth consent screen. You click that to go to that tab. You'll select an email address, enter the product name, if not already set, and click save. So the email address is gonna be the one that you created. It's your attacker's email address that we just talked about at the beginning. And you can name the application whatever you want. So now we're going to go back to the credentials. You're going to hit the credentials tab again. This time you're going to click the create credentials button. You're going to select OAuth client ID. And then you're going to select web application. And then this authorized redirect URIs is important. This is going to go to OAuth Playground. So you'll have to put in this specific address, https://developers.google.com/OAuth Playground. This is the URI that your API request is going to be redirected to. After you click create, you're going to get a pop-up, and this is going to be your client ID and your client secret, which will actually be saved for you. You can see kind of behind it. If you ever want to go back to it, you go to the credentials tab, click on the app that you created, and that's always going to be saved there, so you don't have to worry about writing it down or memorizing it. So this next part, you're actually going to navigate to the OAuth Playground, where we're redirecting this API call to. And from this point, I'm actually going to demonstrate the rest because I'm going to need this API key to show you how this works. So here's the credentials screen tab I was telling you about. Here's the app that I created. Here's my client ID and client secret. So I'm going to need to copy this client ID. I'm going to go to OAuth Playground, come up here to this gear. I need to come down here to use my own OAuth credentials, and you'll see it has a field for OAuth client ID. I'm going to paste that in there. I'm going to go back and I'm going to get my client secret. Paste that in there. Click close. Come over here to this step 1 side, and you'll see there's the Google Calendar version 3 API. Click that one, and then this read-only one. I'm not really sure why I have to do both of these, but if you don't, it doesn't work. So make sure you click on both of those. You're going to click Authorize APIs. For this, my attacker is this John Lear character that I've created. You're going to have to go through all these steps and say, yeah, I allow this web app. Then you come finally to this step 2, exchange authorization code for tokens, and you're going to click this exchange authorization code for tokens button, and it's going to give you this, and it always tries to go to step 3. We don't need that. It gives me this access token here. And that is what we have been working for this whole time. That's the token that you'll need to use in my app, in my Calishing app, in order to communicate with the Google Calendar API. So I'm going to make sure I have that copied. All right, and go back to my presentation. So, Calishing is the open source Python tool that I created to allow you to attack Google Calendars. Again, there's the GitHub. This is all based on the invoke inject G API or G event API. Anyway, it's a PowerShell module for the mail some mandatory arguments that you'll have to use. Attack E is the attacker's email. That's the one that you created. The one that I'm using is John Lear. Attack X is going to be your targets, and basically you can put as many in there as you want, comma separated, no spaces, anything. Just the email address and just the email addresses. Just the email addresses and a comma separating them. All right, I think we're back. And attack A is the access token. That is all those steps we went through, and we just grabbed that access token. I copied it. You have to have a start date time, and it has to be in that format with the dashes and the colons, year, month, day, capital T, hour, minute, second, separated by colons. If you don't have it in that, it won't work. Other thing about this repo is I just threw it together really fast. There's really no error checking. You'll get a 404, 401 and not know why, and it's probably just because you typed something in that I didn't have error checked. So if anybody wants to help out in the repo, feel free to add error checking. I really don't give a shit, but it works for me. So, and finally, the last mandatory argument is going to be attack F, and that's the finish date time. Some other important ones that you probably want to end are like attack T, the event title, because if you don't have a title on the calendar event, it might look kind of fishy. So have a creative title, and then you have other stuff like location. So if your company has like conference rooms that you're able to add to your Google Calendar, and you can somehow social engineer your way into knowing what those are, you can add those, or you can just add places. I typically leave that blank. Attack D is important as well, the event description. That's where you're going to say what this event is, and you can embed your links to your malware or whatever you want to put in there. Attack Z, I actually used for the first time here because I'm not in, it defaults to Central Time America / Chicago, so I changed it to America Montreal. And the rest of it you can kind of look through yourself if you're interested, but there's some other okay parameters you can change. So this is what you end up with pretty much, except now I gotta paste in the attack A part, which was that API key. Here's the tag Z, America, Montreal. What time is it? Oh, I better change these times, huh? Let's take this to 11 a.m. It's a 24-hour clock, by the way, if you didn't gather that from the format here. Change that to 10:30. Got the date correct, right? Yes. Okay. I'm going to go ahead and paste that key in there. Anybody out here have Google Calendar and is brave enough to give me their email address? No? All right. I know I told you I'm a professional liar, but I swear I won't hack you. Well, I'll give you my email address there as one of the victims. And again, it's coming from the tacky jlear.ccf@gmail.com. I'm not going to tell you what CCF stands for. Maybe you can do some open OSINT and figure that out. But in this case, I pretended to be California something Federation. I don't remember. But the point is, make sure you create an address that will trick your victim. And in this case, I created I'm going to navigate down there, you can see that TAC D for the description. I actually took this from a real calendar event that I saw for Zoom. If anybody's familiar with Zoom, kind of like a Google Hangouts thing a lot of companies use. So this is Zoom details, and then I embedded, all right, you can put HTML in here, which is really nice. So did the little line break and then Zoom meeting, and then and then I embedded a link in here and made it look like it is from zoom.us, and then just a random string at the end, which is what these Zoom meetings end up looking like. So click that, and I got a 200 response. So that's good. And get out of here. So I'm going to go to my calendar. And you can see I have an event here that was injected. I didn't accept it. No, I guess I had the time zone off. Wow. Anyway, you see this Zoom link. Now, if I roll over it, and this is something you can educate your client-facing people or whoever you want to educate in your institution. You roll over it, and it's just like any link in your email or whatever that maybe you've already educated your folks on about phishing. But you can see that that doesn't match what that Zoom link is there. But the crazy thing about the Google Calendar is it adds all this google.com stuff in it. So you really have to educate your people on that. This is not coming from Google. Like, you have to read beyond that part, right? So make sure you're telling your folks, like, don't just look at that first google.com and think that this is going to be okay to click on. So if I click on it, yeah, unfortunately there's no sound, but you get the idea. I don't know why. I love rickrolling still. It's like the funniest thing to me. I'm such a kid. So yeah, that's how it works. Really, really easy to set up, right? I mean, there's a bunch of steps I took you through, kind of boring. Well, that's why the time zone was off. But really, really simple to set up. So that's kind of a scary thing, right? For our companies we're trying to protect. If it's that simple, then anybody can do it, and they are doing it. So the next part that I use in particular in my environment, establishing command and control C2. My partner, Cedric Owens, who I'd mentioned before, he created a wrapper. It wraps around, it looks like a Zoom app, right? It wraps around, it's in Swift, and it calls an OSA script, which is calls a JXA payload that AppFell uses. I don't know if any of you are familiar with AppFell, but again, I'm in a Mac environment. It's a great tool put out by Spectre Ops Cody Thomas. And it's a free tool, free open source tool, and it's probably one of the best free open source C2 tools I've ever used in my life. He constantly updates it, constantly adds tons of features to it. So I recommend, if you work in a Mac or a Linux environment and want a really robust and easy to set up C2 tool, that you take a look at it. But yeah, my partner wrote like this wrapper. So it looks like a Zoom link. So basically they click on that Zoom link that I showed you, but instead of getting rickrolled, they're going to go out to our AppFell server that's up in GCP, and it's going to download DMG, right? So at that point, we're hoping that we find victims to double click the DMG because it's labeled like Zoom Updater, and they're like, oh, I guess I got to update my Zoom app. And then a little window pops up once they open the DMG, and we have a little Zoom icon. They click on that, and it's like, hey, do you want to update Zoom? Doesn't matter if they want to update or not. We already got the shell, but they can click that button and feel good about themselves. But yeah, the AppFell GitHub's here. I'm going to have all these links at the end on the slide as well. So getting around gatekeepers, kind of a an issue if any of you worked in Mac environments. Gatekeeper basically enforces code signing. It verifies downloaded applications before allowing them to run. So anything you download from a browser on a Mac, I don't know what that was. Anything you download in a browser on a Mac Gatekeeper's going to take a look at it and basically say, hey, if you want to open this, you need to go to your security preferences and say that it's cool to open this file if it's not signed. I think now though, even with Catalina, and I'm not sure, so we haven't upgraded to Catalina yet. I think like everything, it's mandatory to be signed now. Is it? Okay, I thought that, and it might have actually happened before Catalina, but I knew that was one of the things they were talking about. So getting around this is actually quite easy. I mean, you have to spend $100 to get a developer account with Apple, but you do that. You can create a fictitious, you can get what's called a net spend card. I don't know if any of you are familiar with that, but it's basically a prepaid credit card. You get it, you sign into their website, and you actually like link it to a name and an email address. So once you have that, you can use that card to sign up for an Apple developer account with a fictitious name, fictitious email address, right? Man, Apple's going to hate me. Yeah, and if you don't use a fictitious name, we learned this the hard way, your certs are going to be signed with whatever name you put in there. So if your blue team finds the malware and it's your name on there, they're going to know it's a red team. So just keep that in mind. So one part we were kind of worried about is like, is Apple going to notarize this app? Because it's not doing anything complicated, but it's calling out to a C2 server. We thought that they would be aware of what that looks like, but they weren't. So yeah, they actually notarized it. The way we figured out their practice is they notarize it within like 3 minutes. Like, how the hell do you know what you're notarizing in 3 minutes? But again, we found out the hard way on the first app and burned a $100 developer account because our first instance actually had a credential stealing capability as well, and they did not like that one. So about a week later, all of a sudden our account disappeared and our certs were no good, no warning from Apple or anything. So good news is even if you make something that looks malicious to Apple, you got about a week to use it. So work fast. Yeah, this was just kind of what happens if you look in our little Zoom Updater app, the contents, you can see the code was signed by me, Antonio Piazza. So that's what the blue team found on our first time using this, which was okay. It still worked and gave them practice finding out what it was. This is the Zoom app that we created. This is actually a real Zoom update, and this is ours. We didn't give them the what's new button. And yeah, so it looks pretty similar. Just want to make sure you're not forgetting anything. So the biggest thing I wanted to get across in this talk is how do we stop this? I mean, we already know that Google says they're working on it. I don't see that happening anytime soon because they really called it a feature from the very beginning. I think they believe that. I don't. So I thought I had a partial fix. I was in the shower one day and I got oh shit, and jumped out, ran to my computer, basically looking at Burp Suite, the difference between adding a calendar event normally versus adding it through the API, and unfortunately there was no difference. So that didn't help. Yeah, research fail, right? But honestly, I don't consider any research fail a real fail. That just, okay, now I got to move on to something else till I find the fix. Kind of keep that mindset. I don't get overly depressed about not figuring something out the first time. So maybe our cyber ninjas can save the day. I start talking to my blue team, and we have one of our guys, Ben Phillips. We got his Twitter up here. He came up with the, well, it's like, oh, well, you know, if we look at the user agent string, we can see that it's coming from your tool, this Python. I'm like, oh yeah, it's good. You can see if it's coming from PowerShell, stuff like that, right? So that's a start. We can stop the script kiddies, but like a moment later, I added the functionality to my code to change the user agent string. So it's kind of that back and forth between red and blue. But again, the good news is that if somebody were to grab these tools off the shelf and run them, a script kiddie, and they didn't change that, you know, user agent string or whatnot, we could stop some of this, right? So yeah, this is what he saw. I think this was in Splunk, and you can see the user agent came from Python. Actually, one of the branches I added, I haven't completely added it, but you can change the user agent string if you see one of my branches in my GitHub repo. I just changed it manually, haven't added the actual, like an argument to be able to change it, but that's coming. So the problem is that even if we wanted to do that and add some sort of detection for that in our alert, we took a look at, we're G Suite customer, and we thought, oh, cool, we'll have access to these logs, and we can put in a detection alert. But yeah, so Google's data lag times for getting us the logs is 1 to 3 days. That doesn't really help out too much. But actually, I mean, that's really unsatisfactory. I don't see how they get away with that with paying customers for G Suite. It's not a cheap product. But they did in reality actually get it to us in a few hours, a little better, but still that doesn't help us. So, you know, we have to be able to see this happening in real time to be able to even have any simple fixes to this. Oh, okay. And also, I was seeing a lot of blog posts coming out around the, it was just before DerbyCon time. A lot of people were talking about getting spam through their Google calendars. Like all of a sudden, just when I finished like creating this presentation, all this stuff started popping up. Twitter was going a little crazy about this Google Calendar injection stuff. And then, of course, the cybersecurity community started posting all their blogs on how to stop this. And everybody's claiming that if you uncheck this box, just automatically add events from Gmail to my calendar, that it will stop. It doesn't. So if you go back and read Bo Bullock and Michael Felch's research, they actually talk about in the paper that they wrote, like, there was 2 versions of this attack. One was through email and one was through API. So the email version, it used to be where I didn't have to use the API. I could actually add events to people's calendars through Gmail, like didn't need the API. Google thought that was a little too much, I guess, and fixed that part and fixed it, added this checkbox. But you actually have to go, it's by default checked, so you're automatically going to get stuff added to your Google Calendar. But if you uncheck that, it does not stop the API injection. It only stops the email version. So, I mean, the bottom line here, I open this up to you guys, anybody out here that are blue teamers or defenders, even red teamers that are interested in you know, trying to solve this. But if any of you have any ideas of how we can actually stop this, because again, Google probably won't do it anytime soon. It'd be great to talk to you about it offline and see if we can come up with something, because I'd really like to help our institution figure out how to stop it. And I'm sure some of you will have this problem creep up in the near future. So that is the end of my presentation. Does anybody have any questions at this time? I'll go ahead and put this up. If any of you want to get all the references and links or anything, feel free to come up, snap a picture or whatever. Anyone have any questions at all?
Preset events to be only from people you've only communicated before. It's a very hard constraint because if you haven't communicated with somebody before, it won't show the event. That partially fixes.
Okay.
But the user experience is horrible. So if you haven't, even within your own organization, if you haven't interacted with an email with that person before, yet the event won't show.
Yeah, which can be.
There's a partial fix.
Yeah, no, that's good. That's a good point. Yeah, you're right. Like that probably doesn't work so well for client-facing people because they're going to be interacting with people they haven't communicated with before, right? And sales and stuff. But still, that's good to know. And if your organization isn't set up that way, that could be a partial fix. Thank you. Appreciate that.
Yeah. Why do you think Google is so really?
Yeah, I think they and I'm speculating here. I have no idea what Google thinks. And I just want to caveat, like, I love Google. I have the Pixel phone. I use Google products, so I'm a huge Google fan. So I just want them to fix this. And that's the main thing. I want to keep going out and talking about it because I do think it's a big problem for other organizations who pay a lot of money for these G Suite products. So yeah, I don't know. I think, again, just speculating, I think developing this feature is actually, it's important in a lot of ways. Like, you know, how you get like those flight emails and they add it to your calendar and stuff like that. I love that. Like, I love to be able to, you know, not have to do anything and have my flights show up on my calendar stuff. So it's a great feature. And I think that probably took a lot of work for them to get the work. And then to change that, to fix that problem is probably a lot of man hours. And I mean, not that Google doesn't have money or people, but I don't know. They must know something, like if they change something, it's going to break that whole functionality. That's the only thing I can think of. Again, just speculating. So, good question. Thanks. Sure. Have we had been attacked at all from this? No. Spam though, and then us as the red team doing it. I'm honestly surprised that I don't hear. And maybe it's just nobody's reporting this. It could be a lot of stuff. Attacks don't get reported if, you know, just because there's a successful phishing campaign. Yeah, I'm really surprised that I haven't heard attackers using this as often as I thought would happen. Again, just before DerbyCon time, I started seeing tons of stuff happening on Twitter where organizations were complaining about spam coming to their calendars. And I have seen that. But yeah, no, at least as far as I know, anybody reported out in the public a successful phishing campaign that's, you know, caused a breach in an organization. So I guess we're either lucky or it's just not getting reported. Thanks. Anybody else? Yeah, I have not, and I just moved to a Mac environment. I was working at the Cleveland Clinic before this, and we were in a O365 environment. I had not seen any kind of spam or anything come through in calendars, and I actually, I remember when this came out, and I read it, I was like, oh, I wonder if that works for Office 365. And I went to one of our developers who did a lot of API calls using PowerShell and C# and stuff. He was actually doing stuff with our calendars, and he thinks that there was no way, but you know, I mean, he wasn't like an offensive security researcher or reverse engineer, but I would definitely be interested to know if any smart hackers out there could pull it off on Office 365. I suppose the more attack vectors that are opened up, the more these bigger corporations will want to fix this kind of stuff, and you know, the more attention that comes, that you know, hopefully that'll get them to move on it. But no, I would definitely be interested to know. I never tried. This was over a year ago that I wanted to. Now that I've kind of started messing with Google APIs, I'm thinking I've been real interested in APIs before that. I never really touched them, so I might try to go and see what I can find out at some point with Office 365. Anybody know this might work with 365 or tried anything? No? All right. Good question. Thank you. Anyone else? Okay. Well, thanks very much. Appreciate it.